All right, here's a quick video for maybe the homework problems we didn't get to in class today. It was asked for 49C, which in this case, negative f of x is a reflection over the x-axis. So I'm going to take any points that are our key points. Maybe this corner point is at 1 comma negative 1, so it's going to go up to 1, 1, reflecting straight across there. All the zeros on the reflection line will hit there, 2 down from there. Maybe I'll take this key point, which is at negative 3, 3. So then it's going to go negative 3, negative 3. And then it goes flat from there. Oh, that is not so flat. But I think we get the gist. There's a reflection from there. Okay, properties of exponents for this first one. And anytime I can simplify something before I actually do an operation, please do it. For example, I see a 12 over 3. I don't want to deal with bigger numbers, so I'm just going to put a 4 up top. So I am squaring this, and actually, you know what? I'm going to simplify as much as I can before I even square. You can simplify inside the parentheses if you need to, and I think it makes it a lot more efficient. For example, this f to the negative 9th is in the denominator, so I can move that up as a positive exponent. So I'd be dealing with f to the negative 3rd, f to the 9th, which would be f to the 6th. And then I have a g to the 6th as well, and that's all squared. So my final equation, final expression, I should say, is 16. Don't forget your 4 times 4. If you have to rewrite this, rewrite it. F to the 12th, and then G to the 12th. We also, I only verbally talked about 54b, but I wanted to show it a little bit. And it's kind of using that Pythagorean identity that we had, that if the equation of the circle is this, I can put an x as 1/2, 1/2 squared plus y squared equals 1. So that's where I was saying that we needed to get to 3/4, and I think I said the square root of 3/4, which is correct, but it's not simplified. And Ben did a good job to say, okay, this is 1/4 plus y squared equals 1. Subtract that, I'm going to get y squared equals 3/4. Take the square root, and we should be able to simplify this to the positive or negative of the square root of 3 over 2. So it's that 1/2 square root of 3 over 2 idea that I wanted to link as well. Now, someone asked about 64. This is one that we really need to have solid. Okay, so if I give you the sign of 4 pi over 3, we need to know what that's asking first and then where that is on the circle. So what I would say is we always want a sketch of these. So if I'm going to draw 4 pi over 3, I'm going to draw a rough sketch of the unit circle. If it's asking me sine, I have to know that sine is asking for the y. So it's asking me the y direction of 4 pi over 3. 4 pi over 3 is right here. It's a 30, 60, 90. Pi over 3s are 60s. So across from the 60, the y direction is a negative square root of 3 over 2. That direction right there is the sine of that 4 pi over 3. Try and draw these a little bit bigger. So B, I'll put it here. 11 pi over 3. Again, we want to think about where that location is. 11 pi over 3 is going to be close to 9 pi over 3, which would be pi. So I'll put that out there. That'd be 3 pi, sorry, which is in the same location as pi. Then I have to do 2 more after that. So this is actually in the same location as 5 pi over 3, or it's coterminal to 5 pi over 3. Now this time it's asking for the cosine of that. So here's 60 degrees, which would be then an x value, which is going to be 1/2. Moving on to sine of negative 5 pi over 6. Now I'm going in a positive or clockwise orientation, which would be over here. There's my triangle and my circle. I'll just drop it, dot it around there. Close to that, but not hitting that. So it's asking for the sine again of negative 5 pi over 6. Now that's the 30 degree of pi over 6. The negative, the negative direction of the y direction is negative 1/2. Similarly, if we were to put this in our calculator in radian mode, it should spit out negative 0.5. Now, is it going to spit out square root of 3 over 2? No, it's going to give the decimal approximation for that. So that's why we have to be careful to know what we're talking about and be able to draw this. Lastly, in D, in the green, Sorry for the accuracy. Negative 2 pi over 3. A negative 120. So negative pi over 3, negative 2 pi over 3, negative pi. They're looking for the cosine. Draw my right triangle. There's my 30. There's my 60. Across from the 30 is always the shortest, 1/2. And in this case, it's in the negative direction. So that would equal negative 1/2 as well. Lastly, 2-70 was asked for C and D. So write an equation for f of w plus 2. So when we have extra things inside those parentheses, that becomes our input. So wherever we see an x, we're going to put w plus 2 instead. We'll make that blue. So I'm going to go to my f equation, f of w plus 2 is going to equal 4, and then instead of x, I'm going to put w plus 2 in parentheses, plus 7. And I just simplify from there, distribute, so on and so forth. And then g of k plus 5. G of k plus 5, again, we're going to put k plus 5 in wherever there's a x. So g of k plus 5 is k plus 5 minus 3. I'm still seeing a lot of us distribute this squared. We have to see this as k squared plus 10k plus 25. There are middle terms here. That's amateur hour. We can do better than that. So we have k and 5, k and 5. There's a generic rectangle to get to this, and then just subtract the 3. So it'll equal k squared plus 10k plus 22. So this helps out. Reach out if we need additional help.